All right, now we're going to move on to graphing polynomial functions. So when we're graphing a polynomial function, it's always going to be a smooth, unbroken curve. So if you were to go ahead and look at examples, that would be one. This guy would be one. One looking like a W for Welter would be one. And then something like that. Okay, graphs of these functions do not have cusps or asymptotes. All that means is we're not going to have any ending points like that. And the number of turning points in the graph will be at most one less than the degree of the polynomial, and the number of x-intercepts will vary. The number of y-intercepts is always 1. The domain of a polynomial is always all real numbers, right? Negative infinity going to infinity. And the range of the polynomial function is not necessarily all real numbers. It just depends on what function you're given. So there are multiple steps when graphing a polynomial function. The first one is to go ahead and factor. There might be examples that will already be in factored form, so you don't have to do any factoring, but there might be instances where you will go ahead and factor. The second one is to find and plot the x-intercepts. The third one is to label each x-intercept as a cross, which is just a linear function, right? Okay, looking like that. A bounce, which is a quadratic, so that would be like your y is equal to x squared function. Or a squiggle, which is just your cubic function. Your y is equal to x cubed. Okay? So when we're graphing these, we have to go ahead and look at the x-intercepts when determining if it's going to be a cross, a bounce, or a squiggle. The next one is to find and plot the y-intercept. In this case, all you have to do is plug 0 in for the x and solve or evaluate. And then find the overall degree, which is the largest exponent. All you have to do is go ahead and add all exponents in factored form. And then when determining the end arrow behavior, you're just going to go ahead and ask yourself the question, is the lead coefficient positive or negative? So if you see that you have an even and positive function, we're going to go upwards. Even and negative, we're going to go down. If it's odd or positive, we're going to start going down and then up. If it's odd or negative, we're going to go up in the negative direction, down in the negative direction. Okay? And then the last step is draw the curve connecting all the above steps together. All right, so that was a lot. Let's go ahead and actually apply it to some example problems. So it says examples, graph the following polynomials using the steps above. So our first function, we have f of x is equal to x minus 1 times the quantity of x plus 3 times the quantity of x plus 5. So we all know getting your x-intercepts, right, just pulling it straight from your function. Here it looks like we have 1 comma 0, we have negative 3 comma 0, and a negative 5 comma 0. It looks like when we are going ahead and labeling the x-intercept as cross-linear, right, bounce quadratic, or squiggle cubic. In this case, it's all going to be cross. So I would go ahead and label that guy. All right, let's go ahead and actually graph it on our graph. There's 1 comma 0, negative 3 comma 0, and a negative 5 comma 0. And again, they all have the cross behavior. Next is finding the y-intercept and going ahead and plotting it. Again, you're just plugging in 0 for x. So we're going to get negative 1 times 3 times 5. We get negative 15. So it's going to be 0 comma negative 15. That's going to be somewhere around there. And then looking at the degree, it looks like we are degree 3, which is odd. And then our function is positive. So this is our ending arrow behavior. All right, when we are graphing them, they don't have to be necessarily specific. If you want to go ahead and find specific points of the graph, you'll go ahead and like write an X or Y table. But in this case, we could just go ahead and kind of eyeball it. So we're going to start in the negative direction. We're going to cross the point of -5, 0. Go back up, cross the point at -3, 0. We're going to hit our y-intercept at -15 and go back up and cross at 1, 0. And that's it. Okay, let's go ahead and do number 2. This function says g of x is equal to a negative quantity x minus 2 squared times the quantity of x plus 3 squared. So in this case, there's different things going on. We first have a negative on the outside of that function, and then it looks like we have bounces, right? The squared tells us that we are dealing with a bounce, the quadratic or the even exponent, right? Right, our x-intercepts looks like we're at 2, 0, -3, 0. Again, these are both bounces. The y-intercept, let's see, right, we get -36. So 0, -36 is your y-intercept. And we're looking at a degree 4, which is even. However, our function is negative, so we're going to go down. All right, go ahead and plot your points. We're at 2, 0, -3, 0. Let's say this is our -6 in our y-axis. We're starting downwards with their function. It's going to go ahead, hit at -3 and bounce. It's going to hit the -36, go back up, hit at 2, 0, and bounce back down. And there is your function. All right, number 3. So number 3, let's go ahead and find your x-intercepts. Looks like we are at a -2, 0. We are at 1, 0, and a -4, 0. Okay, we can go ahead and plot those guys on our graph. There are those guys. Next is going ahead and labeling each x-intercept as a cross-linear, balanced quadratic, or squiggler cubic, right? In this case, we have a cross at the -2, 0. We have a cross at 1, 0, and then we have a bounce at a -4, 0. We can go ahead and find the y-intercept, right? Just plugging in 0 for x. So we get -32, 0, -32. Let's say that's where we are at. And it looks like we are degree 4, which is even. Our function is positive, so our ending arrow behavior is going upward. Again, at -4, we're going to go ahead and bounce. At -2, we're going to cross, and at 1, we are going to cross. So we're going to start upward. We're going to bounce back up. We're going to cross at -2. We're going to go ahead and plot that point at our y-intercept. It's going to go back up at 1, and then there's your ending arrow behavior. All right, number 4. Number 4, this is when we're going to go ahead and implement a squiggle. So we see the x cubed. This is our squiggle. The x minus 2, we have a cross, and then we have a bounce. It looks like, right, we're at 0, 0, we're at 2, 0, -3, 0. Again, we are doing squiggle at 0, 0, we're doing a cross at 2, 0, and we're doing a bounce at a -3, 0. So let's go ahead and graph those guys. Okay. Your y-intercept, again, just plugging it in. Looks like we're going to get 0, 0 as our y-intercept. If we add up all our exponents, we get 6, so it is even, and we do have a positive function, so our arrows are going upward. We are bouncing at -3. We have a squiggle at 0, 0, and then we have a cross at 2, 0. Let's go ahead and start upward. I'm going to bounce back up. This guy looks a little funky, but that's our squiggle. And then I'm going to go ahead and cross at 2, 0. And you are done. So you want to make sure when you're doing the squiggle, you guys have that formation of doing the actual squiggle part. Okay? All right.